Okay, this is page 28 of the ACT math portion of the 2018 ACT practice exam. So this next portion, we're going to actually use this setup for 3 different problems, 35, 36, and 37. So the Smith family is planning on building a 3-room cabin. There's 2 bedrooms and also a living room. We are also told that this floor plan is rectangular, which when I first looked at this, I went, oh my gosh, this isn't rectangular because the opposite sides didn't appear to be congruent. I had to look actually really, really closely at this diagram. It actually is rectangular. For example, you might notice that this is 30 from here to here. This is 36. However, the 30 is measuring the length of the inside rectangle. The 36 is measuring the length of the outside rectangle. So it is actually truly rectangular, but we are having to be pretty careful how we read this. So keep that in mind. Okay, some of the things that we know. Also, this we have a picture of the side view of the cabin. The roof is an isosceles triangle. The base angles are congruent, and so are the legs. We are also told that the walls are perpendicular to the floor. The AC is parallel to ED, which kind of makes sense when you're building that roof line, or the bottom of the roof line. And F is the midpoint of AC. The last thing we're told is that BF is perpendicular right here to AC. Oh, I guess we have one other piece of information. We are also told that during the week the Smiths are going to be actually building that roof. There's a 20% chance of rain each day. Okay, so for number 35, Mr. Smith plans to build a 3-foot wide walkway around the outside of the cabin as shown in the floor plan. Keep in mind, this is a rectangular floor plan, so we want to read it carefully. We want to find the actual area of the flat surface of the walkway. In other words, we want to find the area of the shaded region. So the walkway is the shaded region. So probably the easiest way to do that is to find the area of the outside rectangle. And that outside rectangle, if you have to just kind of be careful to use the correct measurements, are 36 feet by 30 feet. I may have said inches earlier. Sorry about that. So the big one is 36 by 30. And if I multiply those together, that will tell me the area of the outer rectangle, which ends up being 1,080. If I find the area of the inner rectangle and remove that, what will be left is the area of the shaded walkway. So the area of the inner or the smaller rectangle, those have different dimensions here. And again, you can look up here to see. We're looking for those smaller dimensions of 24 feet by 30 feet. So that area ends up being 720. And what I'm going to do is remove the small rectangle from the big rectangle. That operation would be subtraction. We end up with a remaining area of 360 square feet, which is option C. Okay, 36. Mrs. Smith is going to install a ceiling fan in each room. Keep in mind, there are 3 rooms. And is going to place curtains over the 4 windows. Each of the ceiling fans has a price of $52, and there's 3 of them. Okay, there's 3 ceiling fans at $52 each. The price of the curtain for each small window is $39.50, and each large window is twice that. I kind of need to go up and look and see where are we looking at for small windows and large windows. And so we can actually see that in the diagram. There are 2 small windows. Nope, there are 3 small windows, and then there is 1 large window as we look at this. Okay, so what we want to do is just find out how much she's spending on those items. So she's buying 3 ceiling fans at $52 each, and then she's going to pay for 3 small windows at $39.50 each, and she's going to buy 1 large window, and that 1 large window is twice the cost of the small window 3950 times 2. I'm multiplying it by 2 not because there's 2 windows, but because it's twice the cost of one small window. At this point, I would use my calculator, and we would get a grand total of $353.50, which you might notice is not on there, but we want which of the following values is closest to this. So 354 is going to be our best answer. Number 37, Mr. and Mrs. Smith want to actually build that roof. It's going to take them 2 days. We want the chance of rain, assuming that the chance of rain is independent from each day to the next. We want the probability it will rain both days. So when you're looking at probability for more than one instance, more than one occurrence, more than one day, what you want to do is you want to find the probability of each day and multiply them together. So for the first day, it's 20%, and I'm going to represent 20% as the decimal 0.20 or 0.2. And then the second day would be another 20%, and I want to multiply those together. I can use a calculator to help me with that, and I get 0.04 or 4%, which is option A. Number 38, I've got these different expressions. I want to see which one would be an irrational number. So the most famous irrational number is pi. Probably the most second famous is e. But really, any square root of a non-perfect square is going to be an irrational number. We're going to need to follow some rules of simplifying things before we decide if things are irrational or not. But like, if I square root a perfect square, like the square root of 9, that will be rational. However, if I square root something like 10, since that's not a perfect square, that would be irrational. So that's what I'm looking for. All right. Square root of 2 divided by square root of 8. Because these are both square roots, I can just divide 2 and 8 and get 4. That would be on the denominator since 8 is the largest. So I have 1 over the square root of 4. That is a perfect square, and I get 1/2. If that square root can simplify out, then that's called rational. I really have the same type of instance in G, it's just that root 4 is on the numerator because that's where the root 8 was. So this would be root 4 over 1. I'm not going to write over 1. The square root of 4 is 2. Anytime you are squaring something, you will be ending up here, squaring something with a square root, you're going to be ending up with something that is rational. But operationally, the way you can think about this is that root 8 times itself would be root 64, and the square root of 64 is whole number 8. There's a lot of different ways to think about that problem, but we did end up with simplifying out that radical because we had a perfect square. Root 2 times root 8 is root 16. That's another perfect square, which is rational. This must be the one that's irrational. What ends up happening is when you're adding, you cannot actually add the 2 and the 8 together because these are not considered like terms since they're radicals. You'd have to simplify each one. You could use a little factor tree to help you do that. Combine like terms. I still have that square root of a non-perfect square, which leads me to know that this is an irrational answer. So option K. Number 39, we have this line that goes through the origin at the 0.00. It also goes through the 0.104. We can see that below. We want to try to find the value of the tangent of theta. Theta is just a variable. If it really freaks you out, you could change that and move that to x. Well, for most of you, you're probably familiar with thinking about sine, cosine, and tangent by using SOHCAHTOA. If we look at the TOA portion, which starts with T for tangent, this helps us to remember that if we're trying to find the tangent of some angle, whatever angle that might be, we could call that angle theta. We could find that tangent by using the opposite side length over the adjacent side length if we're looking at a right triangle, which might be confusing when you look at this picture because you may not see a triangle. However, we could drop a perpendicular segment and create a triangle. Now the 0.104 moved over to the right 10 units and up 4, which gives us some of our side lengths. And it actually gives us the side lengths we want because we're looking for the side that's opposite theta and the leg that's adjacent. We do not want the hypotenuse. So these are actually the side lengths we want. So the tangent of theta is the opposite, which is 4, over the adjacent 10, And then we do want to simplify that fraction by reducing out a common factor of 2. And we'll get 2/5, which is option D. By the way, you could immediately have rejected anything that used the hypotenuse. All right, the square root of 29 is what the hypotenuse would have ended up being if we did the Pythagorean theorem. Number 40, we have an absolute value equation, and it has 2 solutions, which they often have, but not always. We want to try to figure out which of the following equations below would have the same 2 solutions. So what I'm going to do is look a little bit more closely at this solution. A good process if you're trying to solve absolute value equations is to start by isolating the absolute value portion of your equation. So if you have some additional numbers outside of the absolute value, eliminate those first by using inverse operations. Cancel those. I'm going to cancel this plus 3 by subtracting 3 from both sides. And then I'll do a quick rewrite. The absolute value notation is still part of the problem. Once I rewrite this, as soon as the absolute value portion is isolated, meaning that there's no extra numbers on the outside of that absolute value portion on the left side here, then I can go ahead and split this up into 2 different equations. The first equation is 2x minus 8 is equal to positive 2. The second equation is 2x minus 8 is equal to negative 2. And the reason there's 2 equations is we're looking at finding something that is 2 units away from 0. Well, there's 2 different ways we can be 2 units away from 0. We could be 2 units to the right of 0, which would give us this positive 2, or we could be 2 units to the left of 0, which would give us this negative 2. So I want to try to see which of these equations looks like this. F just doesn't. F just has kind of totally different numbers, so I'm going to reject F. G is kind of an interesting one. It does have the 2's, but I'm going to look a little more closely at that. I'm going to reject H, which doesn't have either one of the 2's, and J. And I'm going to focus in on both G and K and try to figure out which one of these would be equivalent to the negative 2. I'm feeling pretty good about this first equation both times, but it's a second equation that I'm not so certain of. So I'm going to just look more closely at K. On K, if I wanted, I could get rid of this negative that's multiplying the entire left side by dividing by a negative 1. If I do that, I have 2x minus 8, which equals negative 2, which is a direct match with my second equation. So it's option K. G's close. It doesn't, if you actually solved the second equation for G, you don't get quite the same answer as you do for the second equation of our absolute value solution. All right, that is the end of the solutions on page 28. If you need to see solutions on a different page, you are going to need to go to a different video.